We have done questions based on important concepts of electrochemistry in the last two videos. And today we will be solving more problems by applying interesting concept of your molar conductivity and degree of dissociation for weak electrolyte and Faraday's constant. And you have to always remember that 1 Faraday is equal to the charge, which is 96500 coulombs approximately. Okay, and 1 Faraday is the electricity carried by 1 mole of electron. So therefore the value of Faraday's constant we get by multiplying charge on one electron and the number of electrons in 1 mole of it. So we will be doing question 3.11 to 3.14. Come to the very first question. In the question, when you are solving any numerical, first look into what information is given to you and first note down the given information. So in the given question, first they have given you the concentration of acetic acid solution, which is a weak electrolyte. This is the concentration of acetic acid solution, and second information is conductivity is given, and the conductivity of this solution is 7.895 into 10 raised to the power minus 5 Siemens per centimeter, and you have to calculate the molar conductivity. And the third information which is given to you is that is your molar conductivity with its limiting value, or the molar conductivity at infinite dilution is 390.5 Siemens centimeter square per mole. So these are the three informations given, and we have to calculate here the molar conductivity, and we have to find out the dissociation constant for this weak electrolyte. Okay, so now after noting down the given information, then we will move and we will use a particular formula to calculate the quantity that we are required to calculate. That is, first we will calculate the molar conductivity, and when you are writing down the given information, it will help you to find out which formula you have to use for a particular type of calculation. So for molar conductivity of any solution is given by the formula conductivity multiplied by 1000 divided by the molarity of the solution. And here we already have all the information which is there in the formula on right hand side. So we will put down the values. So your conductivity value is 7.895 into 10 raised to the power minus 5 Siemens per centimeter, then 1000, and in the denominator we will have the molarity in moles per liter. Okay, so molarity is 0.00241 moles per liter. Okay, this is now you will be getting, after multiplying and the dividing value, after simplification, you will be getting the value 32.76 Siemens centimeter square per mole. And one tip here is, for any quantity that you are calculating, you should be very much clear about its unit. And at the time when you are doing numerical in your exam, don't try to simplify the units, because that will create a confusion and it will waste your time. So focus on the quantity and remember its unit. And if you're writing correct unit for every quantity, automatically your answer will be in the required unit. Okay, now we'll move to the second part of the question. What is its dissociation constant? So dissociation constant. Now here acetic acid is a weak electrolyte. So for a weak electrolyte, we will write down the degree of dissociation, that is alpha. Degree of dissociation, or alpha, for a weak electrolyte is equal to your molar conductivity at the given concentration divided by molar conductivity at infinite dilution or the limiting value of the molar conductivity. So we will put down the value here. Molar conductivity we have already calculated in the very first step, which is 32.76, and molar conductivity at infinite dilution or the limiting value is given in your question. It is 390.5. Both are having the same unit, therefore you will get your answer as 0.084. This is the degree of dissociation. Okay, now we will apply this degree of dissociation, or we will utilize it to find out the dissociation constant. If we look into the dissociation of acetic acid in this question, so acetic acid is a weak electrolyte. It will dissociate partially into acetate ion and H plus ion or the hydronium ion. And if we see the initial concentration, that initially before dissociation, this is the concentration of acetic acid, and these are the concentration of acetate ion and H plus ion. But at concentration at equilibrium, because here it is a weak electrolyte, so ions will be produced, and once some specific amount of ions are produced, further dissociation will stop and system will come in equilibrium state. So here the concentration at equilibrium will be, if till equilibrium alpha is the degree of dissociation, then amount of acetate ion will be C alpha, and amount of H plus ion will be C alpha. Therefore amount left will be 1 minus alpha. Okay, therefore fraction left is 1 minus alpha. Therefore we'll write it as 1 minus alpha multiplied by C for the acetic acid left once equilibrium is attained. Okay, now we will calculate the equilibrium constant, which is the dissociation constant also in this case, and this K is equal to the term on the product side, that will be C alpha multiplied by C alpha divided by, on the reactant side we are having C1 minus alpha. Okay, so we'll be getting here C alpha square divided by 1 minus alpha, and we will put down the values here. Values are first is given, that is 0.00, this is 241, yeah, it is 241 multiplied by the value of alpha which we have calculated, which is 0.084 divided by, you will write down 1 minus 0.084. okay, and you will get your value of dissociation constant, which is equal to 1.86 into 10 raised to the power minus 5. So this is your answer, that is your dissociation constant value, and the first value is your molar conductivity. So this is the molar conductivity value, that is first answer. I hope it is clear. Come to the next one, 3.12, and what is given, how much charge is required for the following reduction. Okay, so you have to be very clear about what is given. They are asking for the reduction process. So 3 examples are there. In every case you have to apply the idea of the reduction, and we know the reduction process takes place by the gain of electron or decrease in oxidation number. Okay, so we will start with the very first example, and in this case if we see the reaction at the specific electrode, it is reduction, so it should be at cathode. So reaction at cathode is written as, we have aluminium ion given, and these aluminium ions are converting to aluminium metal, neutral metal, and we know that one ion has got charge 3 unit positive charge, so therefore to nullify this charge we need 3 electron per atom. Okay, So if you have 1 mole of aluminium ion, you need 3 moles of electron to get 1 mole of the metal. Okay, be very clear what we have and what we need. Only then you will not have any confusion. Okay, now here what we have to find out, the charge required. The quantity that we have to determine is charge required. So we will calculate for this charge required. For what? For this conversion of aluminium ion to aluminium metal, charge required will be 3 Faradays. Okay, why? Because one ion require 3 electron, therefore 1 mole of ion will require 3 mole of electron, and charge on 1 mole of electron is equal to 1 Faraday. We have seen in the beginning. So charge on the 3 mole of electron will be 3 Faraday. Okay, so this is equal to we will put down the values of Faraday's constant, that is 3 multiplied by 96500 coulomb. So answer will be 289,500 coulomb after multiplication. Okay, here the idea which you have to remember is that charge on 1 mole electron is equal to 1 Faraday. That is the idea for the Faraday's constant. So this is the answer for the first part. Now come to the second part. In the second part, the reaction at electrode is given as again reaction at cathode, because reduction process. So reaction is given as your copper ion, that is cupric ion or Cu2 plus ion, are undergoing reduction by gaining electron to give you metal. Now again here, if we have 1 mole of copper ion or cupric ion, we require 2 mole of electron, because 1 ion require 2 electron, and we will be getting 1 mole of the metal. So therefore charge required in this case for the given conversion is equal to 2 Faraday. Why? Because 2 moles of electrons are required. So we will put down the value 2 into 96500 coulombs, and you will be getting answer 193,000 coulomb as the charge required for this particular conversion. Third part. In the third reaction, it is given we are having the permanganate ion, the ions that we have in case of potassium permanganate. Okay, permanganate ion, that is MnO4 minus, and these ions, when they go under reduction, they will form as positive ion of manganese. Now in this case directly we cannot show addition of electron, okay, because with manganese on the reactant side we have oxygen atom also. So in such cases it is better to write down the oxidation state of the metal which is undergoing conversion. So here manganese in undergoing conversion. Here oxidation state of manganese is +7 in permanganate ion, and it is coming to +2. That is decrease in oxidation number. Therefore, it is reduction process. So the same idea we can rewrite in a simplified way is your manganese ion with 7 unit positive charge will take 5 electrons to get Mn2 plus ion. Okay, so just a moment. Now again we will apply the idea in the same manner as we did. For 1 mole of your permanganate ion, which is having Mn7 plus form, will require 5 moles of electron to convert to the required form. Okay, 1 mole of Mn2 plus. Therefore, charge required in this case for the this specific conversion is 5 into 96500 coulomb, which is equal to 482500 coulombs. So this is your answer. So our first answer is this one, or you can write it as 3 Faradays, but you should write the value here 2 Faraday, and this is the value in coulombs, and here we are having the 5 Faradays. Therefore we are having, this is the value of in terms of coulombs. I hope it is clear. Next question is also a continuation of the same idea. So if you are clear with this one, you will be able to solve the next question with ease. First one, what they have given. How much electricity in terms of Faraday is required to produce? First is 20 gram of calcium from molten calcium chloride and 40 grams of aluminium from molten Al2O3, that is aluminium oxide. In this case, what is your given information? Given information is we have 20 grams of calcium, and in the second part we have 40 grams of aluminium. That is we require 20 grams of calcium and we require 40 grams of aluminium, and calcium from calcium chloride and aluminium from aluminium oxide. Okay, and both are in the molten form. Okay, they are in molten form. Always remember, when any electrolyte is in molten form, then we will write down the ions in molten form as ions in the liquid form, and whatever ions are produced in molten form, they will be produced at cathode and anode. There is no secondary or any other reactions as we have in case of the aqueous solution. Okay, so things are very simple when the electrolytes are in the molten form. Simply you have to write down the ions and you can write down the substance produced at cathode and anode. So the first part, in the first part, we need calcium from calcium chloride. So therefore, we have to start from calcium chloride. Okay. So here you have calcium chloride, CaCl2, in molten form. What is the meaning of molten? Molten form means we have heated the electrolyte at a temperature which is higher than its melting point, so that your crystal lattice will break to give you respective ions. So we are having di-positive ion of calcium in the molten state and negative ion of chlorine in the molten state. To balance, we will put here stoichiometric coefficient 2. This is what is the basic reaction. Okay. Now this Ca2 plus ion will, that is calcium ion, will take electron and it will convert to the calcium metal. Okay, so this Ca2 plus ion will take electron because there is 2 unit positive, therefore we need 2 electron per atom to give you 1 atom of calcium. Fine. So here we will apply the idea. What is the idea? If we have 1 mole of calcium chloride, okay, we will be having 1 mole of your calcium ion, because per molecule of calcium chloride we are getting 1 calcium ion. So therefore 1 mole ion, and this 1 mole ion will give you what? 1 mole of metal by utilizing 2 moles of electron. Okay, that is 2 Faradays of electricity. Fine. Now we will calculate the idea, that is we will apply the mass. Now you know, in this case what we have to calculate first, we know that number of moles, here we have to calculate number of moles. So number of moles is equal to mass over molar mass. This is a general formula. Okay, we'll do it separately. So number of moles is equal to mass over molecular mass, and your molecular mass of calcium is 40, or molar mass is 40 grams per mole. Okay, so therefore we will calculate number of moles here. So number of moles of your calcium will be equal to, mass is given to you 20 gram divided by 40 grams per mole. So you will be getting here answer as 1/2 mole. Okay, now come back to the idea we were discussing. So if you have 1 mole of your calcium ion, it is better to write it down to avoid confusion. So if we have 1 mole of calcium ion, we require 2 Faradays of charge or electricity. Okay, so for 1 mole Ca2 plus ion, we require what? 2 Faradays of electricity to give you calcium metal. Okay, that is to give 1 mole of calcium metal. So for half mole of calcium ion, we will need what? How much electricity? It is half, that is number of mole, multiplied by 2, that is 2 Faraday. We will get 1 Faraday. Okay, so electricity required in this case is what? 1 Faraday. This is your first answer. Now come to the second part. In the second part, what we have, 40 grams of aluminium from molten aluminium oxide. Okay, so we have your aluminium oxide. We will write down first equation. So aluminium oxide, that is Al2O3 in molten form, that is liquid form, will have aluminium ion, which are tri-positive ion plus chloride ion, that is, sorry, oxide ion. So we will write down here oxide ion. O2 minus ion. Okay, and to balance the charge, what we will do here, we will have 2 aluminium ion and 3 oxide ion to balance this charge. Fine, this is the balanced equation. Now what is the idea, what we need? We will see now how many electrons are needed per atom of aluminium or per ion. So if you write Al3 plus, this is 1 ion of aluminium. 1 ion of aluminium will require 3 electrons to give you aluminium metal. So if you have 1 mole of aluminium ion, you will require 3 mole of electron to give you 1 mole of aluminium metal, which is what? Which is 27 gram. Why? Because molar mass of aluminium is 27 grams per mole. Like the same idea that we have in this case. Here 1 mole of calcium means what? 40 grams of calcium, because molar mass of calcium was 40 grams per mole. Okay, so therefore we will apply the same idea in this case also. Here number of moles of aluminium will be calculated as mass over molecular mass. Mass is given to you 40 gram, molecular mass is 27 grams per mole. So you will be getting value of N as 40 by 27. We will not simplify here, we will do it later on, moles. Okay, this is the number of mole. We will separate this calculation. Now come back to the problem. So 1 mole of aluminium ion require how much charge, how many electrons? 3 moles of electron. That means 3 Faraday of charge is required for 1 mole of aluminium ion to get 1 mole of metal. Okay, so 3 Faraday. Therefore, 40 by 27 moles of aluminium or aluminium ion will need how much? We will have 40 divided by 27 into 3. So you will be getting answer as 4.44 Faraday. So this is your second answer. Okay, here we will not give answer in terms of coulombs because they are asking how much electricity in terms of Faraday is required. Okay, so we'll write down answer in Faraday. In the previous question, have a look here, the same idea. We were supposed to find out charge required. Okay, so therefore we will give our answer in Faraday as well as in the coulombs, but here specifically they are asking in Faraday, so we'll give answer only in Faraday. This is your third question. Now come to the fourth one. In the fourth one, they are asking how much electricity is required, that is electricity required in coulombs. It is specified here for the oxidation process. Here process is oxidation. In the last two, it was the reduction process. And we have two examples, so we will write down first one. Now, you know oxidation is what? Oxidation is loss of electron or increase in oxidation, increase in oxidation number. Okay, so the first part, in the first part, we will write down the first reaction. We have water initially, and this water is having change in the form that your oxygen is undergoing oxidation here, plus half O2 plus 2 electrons. Okay, here have a look here how we can say oxygen is undergoing oxidation. In this case, the oxidation number of oxygen is -2, and here oxidation number of oxygen is 0. Increase in oxidation number is your oxidation. Okay, so here what we have, we start with in the same idea. If we have 1 mole of water molecule, we will be getting 1 mole of oxygen atom or half mole of O2 gas. Yes, because the stoichiometric coefficient here is 1/2 for 1 mole of your water. So you have to be very much clear to avoid any confusion. So quantity of electricity required is equal to what? How much electricity required? Here, how many electrons are required for this process? If we have 1 mole of water, we need 2 mole of electron. So therefore 2 Faraday. Okay, and therefore what is the idea? It will be 2 into 96500 coulomb. It will give you 193,000 coulomb. So this is your first answer in this case. Now come to the second part. In the second part, we are converting ferrous oxide into ferric oxide. Okay, and we will start here again with 1 mole of ferrous oxide. So for this process, we will require some oxygen, and we will need 1/4 of oxygen molecule or half oxygen atom. It is nothing but what? It is half oxygen atom. Okay, so don't get confused why I'm writing 1 by 4. And here we will be getting 1 by 2 half mole of Fe2O3. These are the stoichiometric coefficient to balance the equation. Okay, so here what is the conversion, how oxidation process is taking place? Your iron from +2 oxidation state is converting into +3 oxidation state by the loss of 1 electron. So therefore, if we have 1 mole of Fe2 plus, we will require 1 mole of electron. Why? Because 1 mole of Fe2 plus means 1 mole of FeO or ferrous oxide. So therefore, quantity of electricity required will be equal to 1 Faraday, which is equal to 96500 coulombs. This is your answer. This is all for today, and I hope these solutions are clear to you. If you want me to explain more questions of this type, please message me in the comment box. And for the NCERT exercise, we will continue for the last 4 questions in the next video. Thank you.